In this video, we're going to consider the function f of x equals x squared plus 1, and we're asked to graph its derivative. Well, there's no reason not to. Its derivative is also a function that should have a graph. So, step 1, let's find the derivative. F prime of x is equal to the limit as h approaches 0 of f of x plus h minus f of x all over h. All right, so on the top, I'll expand this out. X squared plus 2xh plus h squared plus 1 minus x squared minus 1 all over h. The x squareds cancel, the 1's cancel, and nicely enough, everything else has an h in it. 2xh plus h squared all divided by h. (2x) plus h, as h tends to 0, is just 2x. F prime of x is equal to 2x. So this is really a command to graph the line y equals 2 times x. So my y-intercept is the origin in this nice happy linear function, and then up to and over 1. Here is y equals f prime of x. Okay, so in purple I have the function. In red, what I have graphed is a function that follows this recipe. I plug in an x, I'm supposed to get the slope of the one in purple. So let's examine that. If I thought about a tangent line right here, it has negative slope. And that's why we see that point on the graph of the derivative. Right, because x comma slope, well, that's negative and it's pretty steep. In fact, we could see it's supposed to be minus 4, right? That slope's minus 4, so I plot that point down there. The tangent line here is not quite so steep, but still has a slope that's negative. And the point on my derivatives graph has a negative value. Right here, my parabola would have a horizontal tangent line, and that's why the derivative is equal to 0. And then over here, I see all of these positive sloped tangent lines where my first derivative is positive. All right, so I found a derivative and I graphed them together. Now I have an example where instead of having a formula, I have a function defined implicitly, right? Just drawn out for me. And I've been given the similar instructions to graph the derivative. And so I need to look at each piece and just do my best and see if I can figure out what's going on. So in this first piece, right, that is to the left of 1, 2, 3, 4, to the left of minus 4, that's a line. All right, so the derivative of a line is its slope, right? Well, this line goes over 1, 2, and up 1, 2, so 2 over 2 is 1. So its slope is 1. The graph of the derivative of that piece would just be that constant function, right? That horizontal line at y equals 1, always reporting the slope of this piece in purple. I use an open circle here because I see a corner. The first derivative does not exist at a corner, so I can't plot a point there. This next piece I have to think very careful about. It's not quite as easy. It's not always the same slope. But I see an important thing here. The slope is 0 right there. So if I plotted a point that was x comma slope, I would have to plot a point at 0. That tangent line has a negative slope. That one does too. And it looks like they're getting bigger. The lines look like they're getting steeper the closer this way I go. So this is a negative number, and this one is a negative number, but closer to 0. So I'm just going to take a guess. I can't put quite a value on it, but maybe that's like at minus 1, and then my slopes are tending towards 0. So something like that. And I'm kind of thinking that this might be part of a parabola. And the last time I drew the derivative of a parabola, I drew a line. So I'm going to draw a little line segment there. On this side, my slopes are positive, going to this sharp place. So I'm just going to continue that line out. And I don't know how accurate that is, right? I'm just doing my best to sketch the derivative. All right, now I look at this piece and, well, it looks like a copy of that one, right? Negative slopes going to 0, becoming positive slopes. And so I think it has exactly that same behavior. And again, I have a corner where a derivative doesn't exist, and that's where these open circles are going to remind me that I don't have a derivative there. This piece, these are all horizontal tangent lines. That means the derivative is 0. All right, so I took the graph of a function, and by thinking about the slopes, I was able to draw the graph of its derivative.